Hi everyone, this is Brenna from Buildpulse. Thanks everyone for joining the webinar, and today we're going to be talking about the future of facilities management. I just want to introduce Brice, Kosnik, and Steve Ricard. Brice Kosnik is the CEO and founder here at Buildpulse, and Steve is implementation consultant at Fiix, and I'll hand that over to them at this point.
Thank you, Brenna. So Steve and I are
Thanks, Brenna.
Excited to join you guys today. And we're going to be talking essentially about the changing face of facilities management and the workplace in general. We want to talk about optimizing workflows and cutting down repair times. Essentially, a lot of this is going to be about automation and finding ways to clearly move out of manual processes. We want to be able to. We're going to talk hopefully about enabling a more seamless experience between the building automation system and the CMMS. And then really the changing workforce. So what's happening, what are the challenges that we're going to be facing over the next couple of years, and how are we going to move away, or how are we going to solve those problems? So with that, we'll just jump into it. We're going to have a bit of an open discussion. So Steve and I will be just kind of going back and forth and talking in general terms about a lot of this stuff. And you're welcome to ask us questions in the chat box below. Brenna will be monitoring that, and she can jump in and ask us anything as it pops up. So with that, let's start talking about what's changing. So if we look at current construction trends in the US, we're going to see about 40% lift in construction growth by 2025 and 70% growth globally by 2025. So things are still moving rapidly, obviously in conjunction with population growth increases. We're building more buildings, we're building more commercial buildings, and we got to have people to manage and maintain these facilities. We need to have skilled trades that are able to build the buildings and help manage and maintain these buildings. So, Stephen, anything that what are you seeing from your end with regard to construction growth and the speed at which cities are changing?
We're seeing the same thing. For instance, up here in Toronto, where our home office is, everywhere you turn, you're just seeing cranes. The growth is unbelievable. And obviously with that growth, there's going to be the growing needs of maintenance management. And not our grandparents' maintenance management, but we need to progress as we get smarter buildings in place. We need to make sure that we can provide smarter solutions for folks.
Yeah, and obviously with a lot of new construction, we're seeing much more intelligent systems go into these buildings. The control systems have gone from no controls to pneumatic controls to digital direct controls, and the interfaces and the way that those communicate within themselves and operate has, over the last 5 years, really expanded and tried to catch up with the rest of the tech industry and try to keep pace with that change, something that it didn't do for years on end. So with that, we're seeing a lot of changes in demographics as well. One of the big challenges that we hear about, or that I hear about when I go to ASHRAE meetings or FM meetings, is we can't hire people. So there are, we have jobs that have been open for a year, 2 years. We can't get people to apply. We can't get skilled people to apply. My facility management or my facility technicians are leaving to go work in construction because they're getting paid more. We can't keep people in the door for internal facility management, and we're getting baby boomer generation is retiring, so they're gonna open up about 5 million jobs in the next 2 years. So 5 million people are going to retire baby boomer wise in the U.S. alone, and 31 million positions overall are going to need to be filled by 2020, and this is current census data from December of 2017. Some of the oldest, in particular, blocks come out of electronics repairs and skilled trades. So electricians, plumbers, HVAC, they're 45 plus, 55 plus, and they are wanting to retire. So, we're hear a lot of this from our clients. We work with a lot of universities, school districts, governments, and it's a lot of the same, from owner occupants or owner operators. From their standpoint, how do they retain people and capture knowledge? So it's a major challenge. Stephen, Stephen, are you seeing similar trends?
Absolutely. And one of the big problems I'm seeing is that the knowledge base of Bill, who's worked at an organization for 30 years, the most senior person on staff, he has all that knowledge in his brain, and that he tries to transfer that knowledge, but as he goes through retirement, there's no true documentation of that. So it's not just the loss of the personnel that we're going to see, it's that loss of knowledge base that we really need to work with. Start that process now to make sure we can get all that knowledge from him, put it in a centralized location so future generations can learn from Bill as he retires.
Yep. And you look at the younger generations today, they're not as mechanically inclined as the older or the more experienced generations that have come before us. So, when I look at my kids and I see how they interact with the world through iPads and things, it's a changing world, and it's changing fast. So, finding those skilled workers, whether it be industrial engineers, mechanical engineers, civil engineers, or heating and cooling experts, it's going to be this is the challenge we are faced with. This is what we have to focus on, and how we're going to centralize and use technology and automation essentially to try to solve this problem. So that's really we want to keep this in mind as we move forward. And when we're talking about facility management, there's different buckets that we want to talk about. Energy and utilities, obviously, that's an important one. We have to stay within. We have operating budgets that we have to manage and maintain. Maintenance and commissioning, it's important. You got to change your belts, filters, grease. You got to get, every 7 years, 10 years, if you're a public institution, you're having a commissioning agent come in and do a review of the building for performance reasons. Steve, what are you seeing for asset management and training and documentation, how critical those are within FM?
Yeah, on the asset management side, we're seeing again that those bills going to retirement, and assets not being maintained the way that they were originally intended to, because again, that documentation just doesn't exist. So with the right solutions out there, we want to start moving the documentation into a centralized location, and we want to do a better job of tracking people's training to find out when their certifications are going to expire and get those renewed. Unfortunately, with that drain, I think the electrical phase had the biggest drop off, and every environment needs an electrician in the maintenance world. So hopefully we can start getting people more into the trades, and on a management side, be able to track those certifications and keep building off them so that we can get a more informed workforce out there.
Yeah, no, absolutely. So I'm going to move forward. Well, I guess, when we talk about a lot of this stuff moving forward, we want to talk about the manual workflows, right? They're not scalable. So this concept of just throwing bodies or hours at fixing problems as they come up as emergencies, is not going to scale long term. It's also not how the younger generations are used to doing things. They're not, they're more inherently automated. So if we look at, what the work cycle looks like today, no matter whether it's, HVAC control system or plumbing issues within a building, we're talking about manual identification of problems and issues, and then we have to prioritize those items, fix the items, and then verify that they were fixed if we have time. A lot of times with our clients, we don't even see the verification happening. It's just identify, prioritize, fix, identify, prioritize, fix, and then, if they're lucky, they can verify that it was fixed properly. So, but if you can't verify that these things are being done because you don't have time, then the problem that we run into, or that we see people run into, is that a lot of times those issues that they're fixing may not get fixed correctly, or they become nuisance problems that pop up recurring problems that pop up over and over and again. So what we want to do is really automate this away so we can free up that time for verification. The result of that is, from our case studies and from what we've seen with our clients, is a significant improvement in HVAC-related O&M hours, about 50% reduction, in fact. So the amount of time we spend trying to identify and prioritize, we can cut that in half. And then we see a significant drop in a 30% decrease in HVAC-related problems over time, mainly because through automation, you're able to identify the root cause of an issue, not necessarily take a guess at it, and make sure that you have the parts and pieces that you need to fix a problem up front, as well as the information, the ability to capture the knowledge around a piece of equipment. So if it does come up again, we can more effectively and more efficiently solve the problem. HVAC-related complaints, or complaints in general, 40% reduction from getting into more of a proactive or preventative maintenance mode with some type of automation component, and then a 10% asset reduction in asset breakdown or premature asset failure. So this is specifically, we spend a lot of money on chillers and boilers and pumps. If we're not running those pieces of equipment properly, they're going to die early, or we're going to see a drop in lifetime. On an improved sustainability score, or improved sustainability scores as well, whether that be Energy Star or equivalent, we see very well rated, or buildings that are rated fairly highly via Energy Star, or even like LEED Gold, LEED Platinum buildings, and automation can provide an increase on top of that out of the gate. So, Steve, when you're seeing when you guys are working with your clients, are you seeing similar reductions due to that type of automation?
Absolutely. And one of the great things that we start preaching to our customers is you're moving away from the reactive maintenance into a more predictive maintenance. And with the right types of automation, and I know, Brice, you're going to be talking about this a little more, we can now start getting into that nirvana world of the predictive maintenance rather than preventive maintenance, where we're starting to really get some great metrics because of the new technology that's out there. And we're really going to be able to break down our maintenance based on what should be done off of real life data, rather than off of the manufacturer's recommendations, who don't really understand your environment.
Yep, absolutely. So I want to jump in. I'm going to talk a little bit about energy utilities and maintenance and commissioning, and then we'll let Steve talk about asset management and training and documentation. So, there's been a progression in this field. From pneumatics, we got building automation systems and direct digital control systems. From there, we saw a lot of sub-metering go in, and maybe that's the next thing on your list where you feel that you need to, you can't fix what you can't measure, so you're going to measure you're going to sub-meter your primary equipment, you're going to segment out your lighting, your HVAC, and your plug load, and you're going to start collecting all this data. From there, fault detection and diagnostics is typically the next step, where we're taking even more granular data out of the control system and using predictive algorithms to identify faults and issues that go way beyond the building automation system, what it can tell you today. So the big difference between FDD and why your BAS doesn't do it today is the building automation system was designed to tell you when something fails. The FDD system is designed to tell you when something's going to fail or it is failing. It's also a much more powerful engine typically, where it's not just going to tell you that a pump has failed or that a room is hot or cold. It's going to tell you that an economizer is leaking by 30%, 40%. A DX coil is overcycling or has low charge, things of that nature. So it's much more granular information, much more specific information. It's going to drive efficiencies across the board, whether that be on maintenance or trying to figure out what the root cause problem is, or getting the proper maintenance personnel to fix the associated problem, and having them make sure they have the tools they need to get it done fast. ASO is automated systems optimization. This means that the FDD engine effectively is pulling data out and it learns a whole bunch of information about your building and how it performs. And now we can go and we start to inject data back into the control system or augment the BAS in a way to automatically optimize the system and the building and further reduce energy bills, improve equipment lifetime. So when we talk about doing any of this stuff, whether it's manual commissioning or fault detection and diagnostics or automated CX, we like to talk about going back to the basics. So we want to start with set points, schedules, and sequences. And when we're talking about automation in particular, what's really going to help drive that labor efficiency, which again is important because we need to be doing more with less as we move forward. And there's we're facing a significant scarcity of resource in this field. So we have to automate. We can't just rely on our phone to ring or for people to answer, when somebody's hot or cold. We need to be able to run these reports automatically, get insight automatically, and trust the data coming out of our systems. Trust that our buildings are doing what we think they're doing instead of just, believing that they are. So we like to go back to the basics: set points, schedule, sequences. So set points, it's fairly straightforward. Currently, when we look at clients who have just a BAS, they like to click around on the graphics of the control system, look at their floor plan, look for hot zones, cold zones, or they wait for somebody to call and complain. And the typical answer is, I'm going to just, if somebody's hot or cold, we're just going to increase the set point or decrease the set point and put the system into a heating or cooling mode unnecessarily, without actually solving the root problem, putting a Band-Aid fix on it. So when we look at systems that have problems, there tends to be a lot of overlap. And how do you, when you want to, if we want to avoid systems fighting themselves, so you want to make sure that your set points within your building have a good break or dead band within them. So that's essentially setting a policy in place that says we will not heat a single space above 69 degrees or 70 degrees, and we will not cool a space below 74, 73, or 72, whatever it might be. So long as there's a 2 or 3 degree hard dead band in your building, it really prevents the heating systems and the cooling systems from fighting each other. And automated reporting around this will allow you to verify discrepancies within that standard, make sure that the dead band is in place, and eliminate any overlaps that might exist. So this is just an example from one of our client sites before they began, where they had a large block of overlap between heating and cooling set points, but their night high limits and their night low limits all looked good. They're all in alignment. So, identifying these zones really quickly and verifying that those are in compliance with their set point standard enabled them to reduce the amount of man hours that they were spending, one, hunting for these manually, and two, dealing with comfort complaints from occupants within their buildings. Schedules, we get a lot of, we see a lot of our clients, when we talk about schedules, like, how do you guys schedule a building? Well, we set the schedule in the BAS, we set it and forget it. We believe it's doing what we think it is. We don't actually know if it is. So, automation and analysis, whether that be benchmarking or doing snapshots, observational snapshots, which is what these plots are of what's running in the building. We can see here, this is actually a 800,000 square foot high school. They've got a fair amount of HVAC equipment that runs 24 hours a day. So it runs all day, all night, but they've got good optimal start starting at about 4:30 in the morning. A little bit of equipment kicks on at 3 a.m. and then they have a hard stop at 3 p.m. or a decent stop at 3 p.m. and then a few ancillary zones that run until about 5. And then we're back to that baseline of equipment. This here is an example of a system that was using a series of JACEs integrated to a Johnson control system that the scheduling was being done through Johnson and it wasn't communicating properly to the JACEs. So all of this equipment here that's running at night is the JACEs, or the equipment controlled by the JACE. And this here is the actual schedule that they wanted it to follow, controlled directly by the Johnson system. So it's, we're setting the schedules and we think our buildings are doing what we expect them to, but are they actually? And the ability to quickly verify this on a monthly basis, to just get that report and say, yep, my buildings look like they're doing what they're supposed to. We've locked them in as a baseline, have the system automatically identify when we don't follow those adherences, is a significant time saver. And we can reduce those labor hours that we spend hunting for these types of things. Or, we can avoid those spring breaks or midwinter breaks or Christmas breaks or times that the building should be shut down for a week, 2 weeks, a month, and automatically identify that before it hits our utility bill. So if our buildings are not following the schedules that we've set, we can get that cleaned up. With sequences, we know that every building is different, or we know that every there's some nuance to every configuration out there. What we like to do with the automated side of this is to conform to a standard. So whether the building is LEED Gold, LEED Platinum, or if it's a manufacturing facility or school or university, lecture hall, there's a set of standards out there that can get us 90% of the way there and leave that 10% of nuance for regional experts. So we like to conform a set of automated tests. Just like in software development, when people write, when Microsoft is writing, Microsoft Office, they don't just push code that can break everything. They have a series of automated tests that automatically happen before the code is released. So we want to do the exact same thing in HVAC. We need to bring the systems up to a way that we're automatically testing conformance and performance and conformance to ASHRAE, LEED, or California commissioning guidelines, and then continuously verifying that performance and methodology. So, once we have that, then we can optimize our service labor and the materials that we buy and the processes we follow to correct systems. So I've got a series of examples here just to kind of walk through a few things and show you a little bit of what we're talking about. These are all very different buildings, and but the basics all apply to them. So this is a plot of a rooftop unit that serves a open warehouse. And we can see here, this pink line is, in fact, this is the economizer on that rooftop unit. And this is normal operation. So we were able to create a baseline for normal operation of this rooftop unit so that when it starts doing this, we can identify that quickly and get it fixed. Now, what this is over a weekend period. where the unit was turning on and off nonstop all weekend. Turns out one of the doors to the warehouse had been left open. So everybody had left, everybody had gone home for the weekend, but they left one of the service doors open, which was causing, it got cold out, and it was causing the unit to go into night low limit. So it was doing exactly what it was supposed to, but because of a mistake by essentially an employee and a security guard, the system was having to work a heck of a lot harder than it would have had to normally. Now, the same thing happened. It went into a daytime operation, and then that door was left open again that following evening. So automatic identification of this stuff before it, I mean, this hit the utility bill because they weren't able to fix it quite in time, but it helped with training. They were able to educate people, get things set up so that if the door is open, it prevents the unit from running unless it hits an even lower limit, things of that nature. Failed economizers. So here, this is an air handler that's trying to economize and take advantage of free outdoor air cooling, but we're not seeing that at all. So this pink line is the orange line is the mixed air temperature, which is following the return air temperature pretty much 100%. It's a little hard to see there, the orange line, but it's up here. So this is our orange line, and green line is the discharge air and return. This blue is the economizer. So the economizer is 100% open, trying to take advantage of this free outdoor air cooling. We're not seeing that at all. So this orange line should be on top of the pink line, and we should see the mechanical cooling shouldn't have to run, which it is, because the economizer isn't actually working. So in that case, the economizer has failed shut. Here, this is the blue and red are the heating valve and cooling valve, and they're fighting each other. So the control system is doing what it's programmed to do. So we have we've paid a lot of money for a control system that's going to maintain temperature in a space, and it's effectively overheating and then overcooling, overheating, overcooling, and we're seeing that in such a way and such a rate that we're actually overlapping with the heating and cooling on this unit. So once we have, those are examples of how we can automate the analysis and take better data to our technicians so they can fix problems automatically. Now that we have those maps and we understand how our buildings operate, we can really turn to ASO, automated system optimization. This is where instead of having to rely on a technician or essentially a human being to make a change in a building that's going to make it more efficient or improve the lifetime of our equipment, we can rely on software to make minor changes. So we don't want another program taking over the BAS entirely. We want a program that can modify a single set point and then let the system do what it's supposed to do. But we're gonna write back to a single set point, and we're gonna control to better delta T, better dynamic hydronic pressure set points or dynamic hydronic pressure set points, and then optimize flow. So from a central plant level, we don't have to write to a lot of data from the cloud or from the FDD standpoint, but you can get significant, 15–20% energy savings by operating the central plant better by modulating just one or two set points within that plant. Air handlers, same thing. So they have fairly static set points. They just do what they're going to do. But when you have the aggregate data of the building and its performance ratings against outdoor air temperature and humidity, or a map of outdoor air temperature and humidity, then we have the ability to implement things like dynamic differential pressures and temperatures, get better VFD control, better economizer control to really drive energy savings. So we can come back to this. I'm sure there'll be some questions that'll pop up around these topics, but I'm going to turn it over to Stephen and let him talk about asset management and training documentation.
Sure, thanks, Brice. And to just continue on with your topics there, as a maintenance organization, we're really a customer service organization. And the goal of a maintenance organization is to provide superior customer service to their customer. Now, that customer might be a fellow employee or in a facilities management, maybe you're a property management company. But regardless, you're trying to provide outstanding customer service. Now, you talked about the basics. I remember in 1986 when I started in the maintenance industry, we had a building automation system. It threw up some really nice graphics and could do a lot of things, but everything was proprietary. If we wanted a report, we could print a report out of that system. But if we wanted that system to integrate with anything else, we couldn't. The nice thing, the way the technology is going today, is that everybody is opening their platforms up. So all of those PLCs, DDCs that you have out there, they now are able to give us digital outputs that you can bring in, hopefully, to your CMMS. So a little bit about these acronyms here, and then I'll get into more detail about what that digital data can do for us. So CMMS, Computerized Maintenance Management System. Work orders, inventory control, preventive maintenance scheduling. Enterprise asset management may have all of the features of a CMMS, but then it may also integrate with your GIS system. It may integrate with your AutoCAD system. And then under the ERP, Enterprise Resource Planning, generally will be a very strong purchasing and asset documentation on a financial side, and may include some of the features of the EAM or CMMS. Now back to those meter readings or those digital outputs. When I was in the industry back in '86, nobody wanted to do preventive maintenance based off a meter reading, because the amount of time it took to go around to each device to take a meter reading didn't outweigh the actual performance of doing your PMs. So everybody went into the mode of set and forget. They set up time-based maintenance, and they typically used Bill, the example I gave earlier, who is going to retire in 5 years, and say, Bill, what do you think? And he says, well, in my experience, if we PM this every 3 months, and by PM, I do mean preventive maintenance, not predictive, we should PM this every 3 months, and we should not have many breakdowns. Well, now that we can get into the predictive stage, and Fiix is an example of a CMMS where we can add in those triggers based off meter readings that you're now getting electronically, so you don't have to have someone go out and take those readings. So we are going to improve your schedule. We're hopefully going to get you off the set and forget. Well, actually, maybe not, because you will be able to set and forget. You'll be able to set up the system to automate those meter readings, and you'll see that hopefully that your overall efficiency will improve, because now we're taking the metrics that, Bruce, you guys at Buildpulse are so great at charting out and gathering for us, and we're moving into that nirvana world of the predictive side. On the training and documentation, I mentioned it earlier about keeping track electronically of all the training people receive. How about the documentation? You go into Bill's office, he's got books all over the place. He's got his own Dewey Decimal System. He knows where which catalog is for what, which manual is for what. But let's get that documentation electronically, and let's store that in that central store, and that store is going to be your CMMS. So anybody at any time doesn't have to ask Bill what's his Dewey Decimal. They're going to open up that asset, and they're going to be able to see that documentation directly from the manufacturer. So a lot of people ask, why do we need a CMMS system? We've been doing things the way we've always done them, and it seems to be working pretty good for us. Well, first of all, we can talk about modernization. 51% of manufacturing facilities now use a maintenance management system. And they do that because they realized the work order logbook, the Excel spreadsheet that purchasing is using, and the graphs that they try and put together to pass up to management just aren't cutting it anymore. That they need to move to a simple solution that they can all work together and produce those reports, see those results, and run their maintenance more effectively. When they do that, they see a reliability improvement in their equipment. So Brice, we can use those data points that you brought up. We can see that, hey, the chiller isn't running effectively, and we're not going by Bill's schedule anymore. We're starting to go by real-time data, and we're seeing our overall efficiency and reliability improve. Believe it or not, when people talk about purchasing a CMMS, they think that the cost of implementing and deploying a CMMS is incredibly expensive. Your maintenance budget right now typically takes 40 to 50% of your operational budget. And we're going to see on a slide a little further how much money you can actually save, so you easily offset the costs of implementing a CMMS, and your return on investment really comes pretty rapidly. And then the prevention side. So businesses on average spend 80% of their time reacting. I talked about moving into the preventive and then into the predictive. I had a great conversation with one of my colleagues last night over a baseball game. Talked to him about just how important it is to move off of reactive maintenance and prevent the downtime before it happens. We all know that downtime, whether that be in a manufacturing industry or in a facilities industry, costs us money. In a facilities environment, shut that chiller down and see how happy the folks in your building are going to be. In a production line, shut down the CNC machine and see how many lines down the road that you're going to prevent from getting those pieces and putting out a final product. So we want to help reduce the 80% time that you're spending on reactive maintenance and getting you to a more preventive, scheduling things while they are already down rather than working on them when they go down. This slide always amazes me when I see it. You can save 12 to 18% of your maintenance budget by moving away from a reactive maintenance with the help of a CMMS and the Buildpulse solution. With the help of these solutions, we can help reduce your costs 12 to 18%. We have seen it as high as 30%. This absolutely can happen, and we talk about ROI. There's your ROI. So Bruce, Brice, excuse me, I'm gonna flip this back to you for a little bit. And when we get down to the cloud, we can talk a little bit about how we both work within the cloud.
Sounds good. Thanks, Steve. So talking about unified solutions, there's a lot of different providers out there and a lot of different components and pieces. Whether that be your building automation system or your CMMS or your FDD, your ASO, whatever it might be, and finding there is no real one provider of everything. So we want to make sure that when we're speccing out solutions that can work together, what are some of the things that we want to just focus on, or we want to make sure that they have so that they can work together. open APIs or a documented API that enables intercommunication is absolutely critical. So we have to have that in order to have a common data set and to eliminate repetitive work. And by repetitive work, I mean things like I have a fault in my control system or my FDD, and I need to go manually enter it into my CMMS and cut a work order, or my work order system and cut a ticket. Or I've got one data set in my EIS, and I have a different common data set in my FDD. I need to bridge those together so that they can share or leverage the other's data sets. That is all done through what are called application programming interfaces. And it's for modern cloud software, they tend to be documented, and they tend to be pretty straightforward. A lot of it uses what's called REST APIs. And we just want to make sure that the stuff we're using isn't just servers in our machine shop that are isolated from each other or not designed to talk with anything else, but we want the ability to share that data. That's really critical. When we talk about the cloud and the advantages of cloud, that turnkey integration really can be driven from that. And from a security standpoint, data on the cloud is just as secure as data on your internal network, especially if it's on the internet. So if you have, you just don't have to manage that security. So if you have that, if you have a server that's fully isolated or air gapped, then you can't get better than that for security. But if you have, if you do have, VPNs in, or if you've got remote access to, any of your systems that are hosted internally, then your security is actually probably a little bit less impactful than a cloud solution that's hosted by world security leaders like Google or AWS or Microsoft, for that matter. So a turnkey integration from cloud to cloud or API to API is really enabled at that point, and then we don't have to manually customize, patch, or upkeep or do DevOps work to manage and maintain those. So we can save on labor in that sense as well. And then, it's better uptime. So if our server goes down and we only have the one, or we don't have a backup, we want to make sure that in the cloud environment, there's automatic redundancy and automatic failover, things that go into that are not, don't have to be managed and maintained by an individual within your organization. So, Steve, any additional thoughts or?
Yeah, I'll jump in there. Actually, going to talk about both the APIs and the advantages of cloud. I'll start with the cloud. We do utilize AWS, Amazon Web Services. We figure if their multi-billion-dollar security can withstand the needs of organizations like U.S. Department of Defense, then certainly should be able to withstand the needs security-wise of your CMMS solution. Having said that, we also have security built into our own software. One of the features is that you can firewall protect it. So in addition to the firewalls that AWS puts in, Fiix also offers you to block people from accessing unless they come from specific IP addresses that you define. The better uptime, the redundancy, I believe that we have our data stored in 3 locations in the US and 1 overseas, and that is all redundant data. So if one server goes down, another server automatically picks it up, which virtually eliminates any downtime of your CMMS, an advantage that you may not have if you're housing the data locally. And to jump back on the APIs, I love the fact that people are buying these Google Home and Alexa devices, and they're going to their local Home Depot, and purchasing, and Lowe's, excuse me, and they're purchasing these smart switches that communicate back to their home or their Alexa or to their cell phone. They're turning lights on and off. Well, imagine that same technology in the maintenance world, where it's an open platform. Those smart switches can send their signals into an API that gets picked up by your CMMS. We have a client up in Alaska who said to me, wow, you know, right now, if the weather prediction is bad, I have to pay a man to stay on site to be prepared to plow. With these switches, I can potentially put in a barometric pressure reading sensor. I can put in a humidity detector and a rain gauge, as well as a temperature sensor. And we can take all of that information and set up a trigger that's going to create a work order. And oh, by the way, that work order is going to notify the technician that, hey, you need to get to work. So rather than having the technician sitting around, now the technician can be back with his family, his or her family, enjoying the evening, and then potentially have to go into work later based on this open platform and data collection. Really, really some pretty cool stuff, I think.
Yeah, and it's the way that our, the younger generations are going as well. They're not afraid of this type of technology, and they're able to better accept it. We're not as reliant on control contractors or integration experts as we used to, as reliant on those types of expertise or service providers that we used to be. That's for sure. So excellent. So again, we're facing some labor shortages. Obviously, we got more buildings to manage and maintain. We got more equipment to manage and maintain. And really the name of the game is automation. So if we're going to do more with less, we got to do it with automation. And we need that seamless experience between the building automation system and the CMMS or any platform that you're using to drive that efficiency or that automation. And then, times are changing. We got new bodies coming in. We got to keep them up, get them up to date fast, and get them moving as quickly as possible and safely. So with that, we can take some questions. I think Brendan's got a couple for us.
Yeah, we have some queued up already. So I'm going to get started with a question from Rolando. And he says he has 20 plus years of experience in multi-craft industrial tech. And he says he thinks that the Fiix system will only work or only be well received and executed with a properly trained and skilled workforce. Techs can benefit through good mentorship and coaching from the older generation to improve efficiency. So maybe we could hear a little bit from Steve and Brice about how to train up teams to use the software that we've been talking about and how to get everybody on the same page, really.
So Steve,
absolutely.
Yep. Oh, go ahead.
I'll definitely jump in here. I think this was Ronaldo who asked this question. Ronaldo, if you look around today, what's the big complaint that we're seeing with the younger generation? Every time we turn around, their nose is buried in a device. Well, one of the ways that we can bring them on board a little easier is by making sure that the device they're using, that they're used to, that we have a simple but robust solution that they can easily adapt to. So with Fiix, we do have a mobile solution, and other CMMSs do as well. But we want to make sure that it is as easy to use as possible. We'll operate on devices that they're used to, and will be quickly adapted to. When I went to my first training session on a mobile device, it was an old Symbol, which is now Motorola, Symbol scanner. It was big, it was bulky, Frankly, the person training on it didn't particularly know it well. None of the technicians used those in their daily lives. The hardware technology just fell flat on its face. It was not adapted. So making sure that you have a solution that flows with each generation certainly helps bring people on board a lot quicker. Brice, you want to add to that?
Yeah, I mean, what we found as well, especially from a facilities management side or facilities maintenance side, is really the distribution of equipment. So where is VAV box A located versus VAV box B, or even when working with things like low limit trips or free stats, or refrigeration systems. The ability to capture images goes a long way. So instead of having to walk somebody up and show them the compartment that houses, component A versus component B, or exactly what needs to be done, the last time that this fault occurred, we can snap a picture when we're up there taking a picture or getting it fixed, and start to capture that knowledge, and then capture the notes, right? So the ability to drive that knowledge capture is critical, and then be able to turn it around so that the next time there's a similar problem or something's going on, I need to fix an economizer, or I need to replace a damper actuator, or I need to calibrate a VAV. We have samples and examples of that so that we can really drive that guidance and that mentoring. Apprenticeships, if you don't have, or if you're holding on to that knowledge, and with the idea that you're just going to train somebody by your side over the course of 4 years, that's traditionally how it's done. But if you want to retire and you want to walk out the door, a lot of our clients, a lot of university clients in particular, are desperate to have people not retire because they don't have the staff trained and ready to rock and roll for when that one guy who knows everything about that building or that system leaves. They're going to be in a world of hurt, right? So really, that knowledge transfer and knowledge capture can be automated and given efficiency and timelessness to a certain extent, so that something that we tried 5-10 years ago, and 10 years down the line they want to try it again, but it had a catastrophic event or consequences. We don't repeat the mistakes of the past over and over again.
And Brice, if I can just jump back in, Ronaldo, you're also correct in that a system will only be received and executed with a properly trained and skilled workforce. A CMMS needs to be another tool in the toolbox. It is not an end-all be-all. It does need to be treated like a tool, and people do need to train on how to use all the tools in their toolbox. And you're right, we definitely need to move into a better trained workforce. I think in the US, the skills gap is abysmal. Actually, worldwide, the skills gap is abysmal. We, as a policy, have driven people away from the trades, and we need to get them back into the trades because it's such an important economic driver. So couldn't agree with you more. We have to have the skilled workforce, and we need to rely on the retiring workforce to mentor, and we have to put good educational tools and organizations to provide that training out there for those folks.
All right, so I'll start with our next question. We do have a lot in the queue, so we'll try to get them all answered. Marek is asking, what is Fiix doing about wireless data points, wires from sensors, and the biggest dollar cost for getting data from facilities infrastructure equipment?
Marek, thank you for the question. Fiix is a software provider, so we don't actually produce any hardware. But I agree that those wires are really, really expensive. Because Fiix supports APIs, and we talked about those a little bit during the presentation, we can take those data points, as long as they're able to be pushed out there, we can take those data points and bring them into Fiix so that we can create the work orders or scheduled maintenance as needed. Now, certainly this is an ever-evolving technology, and we would need to work with you or work with whatever organization wanted to go with those wireless sensors to make sure we can build the APIs on both sides.
Yeah, from our perspective, it's very similar. We do have a map though of automation. So to address more of the price per point or what's the most effective. So when we look at things like a rooftop unit or an air handler or a chiller, and if we're missing a sensor, we can say, oh, you should add adding a flow sensor will provide X value and provide Y ROI. Or adding a differential pressure sensor to your rooftop unit or your air handler or whatever it might be, or getting VFDs installed. We can provide guidance around that type of stuff. And then for wireless data points, there's a couple of different platforms out there that are more modern. A lot of them, the older ones, whether they be talking Zigbee Pro or Zigbee Pro, many of them are now just IP enabled, so they work on Ethernet. Wi-Fi, and they don't require a centralized router. But those then go up to a cloud system, whether that be hosted by a Honeywell or a Johnson or Schneider Electric. It doesn't really matter. Those cloud solutions do have APIs that can pull that data back into your FDD or your CMMS.
All right, great. Our next question is from Emily. She's wondering how you're calculating the savings that you mentioned earlier in maintenance costs.
So from the Buildpulse side, we use a weighted estimate cost for faults that are detected. So that is based on an ASHRAE average schedule, and then we have the ability to go and plug in actual horsepowers and voltages after the fact. So we start with a prioritized list based on an average ASHRAE schedule, and then we modify it or make it more accurate from there. For us, it's really about identifying value the fastest. So with the savings numbers that we have from our systems, it's all based on either utility data from our customers and our case studies, and from interviews and looking at their work order management systems to see what their reductions were in labor costs.
All right, great. We have another question from Shivraj, and this is probably more towards Stephen. He's wondering, what are the critical areas where CMMS will be very essential, and if you've done any market analysis, then which industries are more inclined to opt in for CCM or CMMS?
Well, on the critical areas, one of the first questions we ask any organization is, what is your pain point? What are your pain points? So I could identify that a critical area is eliminating downtime and improving overall equipment efficiency. But if your organization is doing pretty well in that area, and you have a really bad MRO, maintenance, repair, operations, materials organization, then I would lean to, well, the critical area is on your inventory, stores, and purchasing. How many turns are you getting? How much shrinkage are you having? So it is I shouldn't say extremely customer specific, but it's definitely, there's some customer specificity to it. The overall broad spectrum is, what do we need to improve upon to provide the best maintenance or customer experience for our customers? we talk with every client quite extensively about where they feel they're falling short in those areas and address it from that point.
Great. So Nelson says, one downside of implementing a system like this, at least here in Portugal, is the instability of the HVAC maintenance contracts. Usually they are renewed annually, and most of the enterprise get apprehensive about installing a system like this. It may be helpful for a year, but the next year it may be useful to some other enterprise that didn't have anything, and with this system, all the hard work is done. Is there any advice to avoid this?
I'll start with that on the CMMS side. And one of the things that I recommend is that generally when you enter a maintenance contract, whether that be an HVAC contract or a fork truck contract or what have you, generally you are promised certain goods and materials. Specifically, you're generally guaranteed that during the length of the contract, your contractor will come in to deliver X number of hours of service. Well, implementing a system where you're generating the work order from our system helps you make sure that your contractor is actually delivering on what they promised. My recommendation is that when the technician shows up, yes, he wants you to sign off on his work order, but you have the technician sign off on your work order. At the end of the year, you can compare what you were promised to what was delivered and then help to negotiate from that point.
Yeah, and if you are going to change maintenance providers on a yearly basis, at least you have that ongoing in a unified system, data capture, knowledge capture, and the ability to verify and drive those contracts based on performance, if anything else.
Mm-hmm. Okay, Joseph is wondering, is it possible to integrate your analytics with an existing CMMS? And I'm assuming this question is geared towards Buildpulse.
So yeah, it's really it goes back to those APIs. So when you're working with a standalone CMMS, something that again is in-house only, there are integrations that can be done. They can be a little tricky. Usually you need like an intermediary, a server, or some type of translator between the two. But it is possible. It just depends on the system and what it is that is trying to be accomplished. The rule of thumb is to have it. You want the systems to work in a call and response method. So if the FDD is going to create a work order or an entry in the CMMS, it needs to call a route on that system, have it do something in the background, and respond with a yes or like an okay or a no-go. And then on the same side, when you're updating from the other side, it should hit a route on the FDD or analytics system and have the analytics system do what it needs to do, and then respond with an okay or a fault. So.
This next one from Naran is for Stephen. He says, please explain about Fiix openness to ERP systems.
Sure, so absolutely open. We do have the APIs where we can integrate pretty much to anything else that is going to put out any type of data points. For instance, we do have a NetSuite integration right now. And without going into too much detail, basically the workflow is the maintenance department, which is responsible for creating requisitions for materials, but not actually responsible for the purchase order itself. They'll create a purchase requisition. That purchase requisition gets passed over to the ERP system, where it flows through your purchasing process. A purchase order is generated from your ERP system, and then that purchase order is sent back to Fiix. And then the receipts are generally done in the CMMS system, generally performed in Fiix, and those receipts get reported back to the ERP. So extremely open, as long as they have a non-proprietary database, we can communicate with them and integrate very well.
All right, I'm going to ask our last question right now. If your question did not get answered, I will follow up with you via email after the webinar. And again, everyone will receive the recording tomorrow if you need to rewatch or if you weren't able to attend. So our last question here is from Shivraj again, and he says, we are in the filtration business, so will it help our clients to maximize efficiency and better maintenance support?
Yeah, absolutely. So moving to, that predictive maintenance, it absolutely improves efficiency. So example of that, instead of replacing a filter on any unit based on strictly a time schedule, you want to do it on runtime hours or on filter loading. So if you have things like cross-filter differential pressure sensors, or if you have a VFD that's providing information on amperage and torque, you can look at how hard the VFD is. You can look at the differential pressure and set a trigger point in a BAS, or if you have a system that can analyze the amperage usage on a VFD at speeds and load, you can determine filter loading based on that and set trigger points. So it'll say, hey, we believe our filter is 50% filled or 80% filled or whatever. It's 85% filled. Time to schedule the next maintenance to replace these filters. So absolutely, same thing on the water side, but it depends on how much data is available. To be honest, so if you're working with a sand filter or you've got deionization systems, it's all about how much data you have and what you can use to leverage. What you can leverage to drive those efficiencies. Stephen, you want to add anything to that? Steve.
Pretty much just echo your thoughts, and you're taking that differential pressure, maybe a magnehelic reading, and you have the set points in your CMMS that if it falls out of range, if it goes too high, then a certain type of work order is created to go potentially replace those filters. If the pressure differential drops too low, then maybe you need to send somebody out there to investigate, did the filters fall out of the rack, what have you. So certainly we can help maximize efficiency and provide that better support. Because as you said, we're now moving more into a predictive maintenance than a reactive.
Yep. Perfect. Well, I want to thank everybody for joining us today. Brennan will get a copy of the presentation out and answer any follow-up questions that come up. And if there is anything, please feel free to reach out to Steve or myself. Our contact information will be in that email that goes out. So hope everyone has a wonderful rest of their day or evening, and we'll talk to you next time. Bye.
Thank you, everybody. Enjoyed the presentation. Hope you did as much as we did.